All right, so we are continuing our discussion of trigonometry. We're going to be on Unit 8, Lesson 6 here on page 105, and we're going to talk about angles of elevation and depression today. And really, this are just applications of what you already know about trig functions. And so these are just problems that appear in the real world. All right, an angle of elevation and angle of depression are specific types of angles that you will see, all right, within certain types of real world situations. So when you look at 19.3 and 19.4, I can use angle, depression, and elevation to solve problems involving sides and angles. And to kind of get you thinking about some of those things, all right, why don't you go ahead and do the opener, all right, pause the video, flip it back on, and we'll see what you get for a measure of angle A. All right, so let's take a look at the work here. And notice there's a little bit of work that you have to do. So we know that the pyramid is 250 cubits tall, and that would be this right here, this height right here, 250. Now notice it tells us that the base, all right, is 360 cubits long, right? And we're assuming this is a square, all right? And we're assuming also that this is a right pyramid, so the center or the point here is directly, all right, above, perpendicular distance, all right, above the center of the base. And that's important because that allows us to assume that if this side is 360, this side of the triangle is 180 degrees. And so all I did was take this triangle right here and I redrew it here just to make it a little bit easier to see. And so here's the height, 250, and then here's that length of half the side, which is 180, and then here's that angle A that we had right here. So you can see that the tangent of angle A is 250 over 180 degrees, or excuse me, 250 over 180 cubits. And then once again, to solve for angle A, we have to do the inverse, all right, of that ratio to find the angle, and hopefully you got that angle A is 54.2 degrees. Now, if you look, all right, this angle goes up from the horizontal, and that would be an angle of elevation. All right, so angle of elevation just means we have an angle and it's always from the horizontal. So that could be your line of sight, that could be the base, that could be the top of something, all right? And it goes up from that, but it's always from the horizontal. And the same thing with the angle of depression. So the angle of depression is from the horizontal, but it goes down instead of up, all right? But it's always, all right, so if you think about going straight ahead, it's always the angle formed either above or below your horizontal. All right, and so it's very important that you understand that. So when we look at, all right, this picture here, right, we have our two pigeons looking at each other, right? So notice the line of sight here for this pigeon, right? This is the horizontal, and notice this angle is going down from that horizontal. And because it's going down, that is an angle of depression. Versus this pigeon, like his line of sight or her line of sight, all right, is right here. And notice this angle is going up from that horizontal, and that would be an angle of elevation. All right, and then notice something, that if this is a horizontal line and this is a horizontal line, all right, the angle of elevation for this horizontal, excuse me, angle of depression for this horizontal and the angle of elevation here are going to be equal because they're going to be alternate angles of parallel lines. All right, okay. So the angle of elevation is always, all right, equal, all right, to the angle of depression from the other perspective. All right, so you always have to have your horizontal, right? So you always have to have that horizontal. All right, so just remember horizontal. I spelled it right the first time, but struggle the second time. All right, that's very important. That's always the angle formed from the horizontal. All right, so if we jump down to, all right, and number 1 here. All right, and so when we look at angle 1 here, I'm going to find angle 1. So here's angle 1. Notice it's touching this horizontal and it's going, you can't really see my black pen on black there, but it's going down. So that would be an angle of depression. All right, so when I look at angle 2, notice angle 2 is not touching, all right, any of the horizontals. And if it's not touching a horizontal, then it can't be, all right, an angle of elevation or depression, because this is angle 2 right here, all right? So it's nothing right here. Now if I look at angle 3, now angle 3 is touching a horizontal. And once again, from the horizontal down, all right? So that would also be an angle of depression. Now find angle 4. So angle 4 is touching this horizontal. All right, and notice now angle 4 is going up from that horizontal, so that means that's an angle of elevation. All right, so why don't you pause the video real quick, all right, and do problem 2 here, and we'll see how you do with this. All right, so let's look at this. Angle 1 is here. It's touching this horizontal, and it goes down. So hopefully you saw that this was an angle of depression. Angle 2 is touching this horizontal, and it goes up from that horizontal. So that would be an angle of elevation. Angle 3, all right, angle 3 touches this horizontal, and it comes down. So that would be depression. And then angle 4 is this angle, notice it's touching this horizontal, and it goes up from that horizontal. So that would be an angle of elevation. All right, so hopefully that makes sense to you with the difference between angle of elevation and depression. Remember, it has to be touching a horizontal. So if it's not touching a horizontal, like angle 2, it can't be either, all right? Can't be either an angle of elevation or depression. All right, so let's flip to, all right, page 106, and let's go through a couple of examples of how we use angle of elevation and depression within context here. So the 9 Lives run at Breckenridge is the steepest inbounds run in Colorado at a 50-degree angle of depression. All right. So if you skied down 436 vertical feet, how many actual feet did you ski? All right. So let's draw our mountain here, right? And we're going to come down the mountain, right? Okay. All right. Now, once again, if we're at the top here, there's the horizontal. All right. And I have a curve here. So we're going to assume, and there's another assumption here, right, that the line you take coming down the mountain as you ski is a straight line, right? And so when we think about that straight line, if we assume that it's a straight line, that would create a right triangle here. And notice it says that the angle of depression, right, so that's from the horizontal, all right, to your skiing pass is a 50-degree angle. All right, and it says you lost 436 vertical feet, right? So that means that this side of the triangle is 436 feet. And it wants to know how many actual feet did you ski? Well, that would be this right here. This would be your pass, so that would be X. All right, so there's our angle of depression. We know this side, that's our vertical change, all right, as we ski down the mountain. And then we want to know this, right? How far did I ski? All right, so once again, now the nice thing is it just goes back to those 3 basic trig functions that we've talked about. So when I look, I have my 50-degree angle, I have the opposite side, and then I want to know the hypotenuse, right? The hypotenuse is opposite that right angle there. So opposite over hypotenuse means I need my sine function. So sine of 50 equals 436 over x. Right, and then once again, make this a proportion. If I cross multiply, I get x times sine of 50 equals 436, right? So I'm going to multiply there. And once again, we're going to just divide by that, because remember, sine of 50 is just some number. And we're going to keep that as just that exact answer there, all right, so that then I get a more exact answer at the end, because I'm just going to divide by that number. So 436 divided by sine of 50. And that tells me that, all right, I skied 569.2 feet. All right, so that was how far I skied coming down, all right, the mountain with that angle of depression being at 50 degrees. All right, so let's do one more together. All right, and let's look at this guy right here. All right, so scientists can estimate the depth of craters on the moon by studying the length of their shadows. Shadow lengths can be estimated by measuring them from photographs. So we want to find the depth of the crater, and notice that's already marked with X for us right here. If the shadow is 400, all right, meters long, and the angle of elevation, all right, of the sun is 48 degrees. And we can see that that's right here. So there's our angle of elevation. All right, so now a couple of small things, right? So we really want an angle in this triangle right here, right? And so once again, here's one horizontal, here's another horizontal. So when I look at these two angles, hopefully you recognize that those are corresponding angles of parallel lines. And we know corresponding angles of parallel lines are in fact equal. So that means that this would also be 48 degrees. All right, so now we have 3 pieces of information in one triangle, which is what we, all right, need, or I should say 2 pieces of information in one that we're solving for, which allows us to set up our trig functions. And so once again, I have an angle, I have the opposite side, and I have the adjacent side. So that means I need my tangent function. So tangent of 48 equals x over 400. All right, and once again, here's that ratio, right, and it's really a proportion. And then I cross multiply, and I get 400 times the tangent of 48 is equal to x. And once again, I can just throw that into my calculator. So 400, and then times tangent of 48, All right, and so that tells me that the depth of, are we in feet or meters here? Meters. All right, is that the depth of that crater is a little over 444 meters. All right, so what you can see, hopefully, is that we just use those angles of elevation and depression to gather more information about our triangles. Then we set up our triangles using what we already know about our trig functions and solve them as we have been doing. All right, we only have a couple of lessons left in this unit, and I will see you when we start talking about the law of sines and law of cosines. All right, take care and finish this up and let me know if you have questions.